Welcome to Digital Learning DCE. I am Dr. Lakshmi Janardhana, Assistant Professor, Department of Mathematics. In this video, I am going to present you BSc First Semester Mathematics. Let us learn the chapter Differential Calculus under Calculus 1. Under this chapter, discussing the nth derivative of e power x into sin bx plus c and e power x into cos of bx plus c. The objectives of this session is to derive nth derivative of e power x into sin of bx plus c and e power x into cos of bx plus c to solve related example. By the end of this session, students will be able to understand to derive nth derivative of e power x into sin of bx plus c and e power x into cos of bx plus c, and they can solve related examples. Prerequisites: the function has to predefine y is equal to f of x with single independent variable, and it has to be differentiable to generate the derivatives. Nth derivative of standard function. Let us derive the nth derivative of e power x into sin bx plus c. Let y is equal to e power x into sin bx plus c. Differentiating with respect to x, y differentiation y1 is equal to differentiate right hand side. Now we have to apply product rule. Differentiation of first function e power x is e power x into a into second function sin of bx plus c plus first function e power x into differentiation of second function sin bx plus c cos of bx plus c into b. Now we can take e power x common factor and rest of the term a into sin of bx plus c plus cos of bx plus c into b. And this y1 term should reduce to given form, that is e power x into sin of bx plus c. For that, now we have to take substitution. A is equal to r cos theta and b is equal to r sin theta, where r is equal to square root of a square plus b square is called radius, and theta is equal to tan inverse of b by a is called modulus. And now let us substitute a and b in y1. y1 is equal to e power x into r value, a value, r into cos theta sin of bx plus c plus cos of bx plus c into b value r sin theta. Let us take our common factor. Remaining rest of the term cos theta into sin of bx plus c plus cos of bx plus c into sin theta. Now this term looks like a sin a into cos b plus cos a into sin b, that is sin of a plus b. Here a value bx plus c and b value theta, that is y1 is equal to r into e power x into sin of bx plus c plus theta. Similarly, y2 is equal to r square into e power x into sin of bx plus c plus 2 theta. See here, if you go for keeps on increase the derivative, keeps on differentiating, you can see only two changes in that. One is r power is increasing as well as theta quotient is increasing. Similarly, y3 is equal to r power 3 into e power x into sin of bx plus c plus 3 theta, and so on. To differentiate n times, yn is equal to r power n into e power x into sin of bx plus c plus n theta. Finally, let us substitute the r and theta value. Then nth derivative of e power x into sin of bx plus c is equal to r value a square plus b square whole to the power of n by 2 to e power x to sin of bx plus c plus n into theta value tan inverse of e by a. This is the nth derivative standard formula for e power x into sin of bx plus c. Now, if a is equal to 1, b is equal to 1 and c is equal to 0, then this nth derivative of the above formula reduces to nth derivative of e power x into sin x is equal to 2 power n by 2 because a value is 1, b value is 1, 1 square plus 1 square is 1 plus 1 is 2 power n by 2 into e power x to sin of bx 1x plus c 0 n into tan inverse of b by a 1 by 1 tan inverse of 1 tan inverse of 1 value is 5 by 4 45 degrees. If c is equal to 0, then the nth derivative of e power x into sin bx is equal to a square plus b square power n by 2 into e power x into sin of bx plus n tan inverse of b by a. One more condition. If a is equal to 0 and c is equal to 0, then the nth differentiation of the above function reduces to sin bx is equal to b power n into sin of bx plus n pi by 2. Because if a is 0, tan inverse of b by a, b by 0, infinity, tan inverse of infinity, pi by 2, 90. So let us take one more nth derivative formula of e power x into cos bx plus c. Let y is equal to e power x into cos bx plus c. Differentiating with respect to x, y differentiation is y1. Again, we have to apply product rule to differentiate right hand side term. E power x differentiation is e power x into a into second function plus first function e power x into cos differentiation minus sin bx plus c into b minus into plus minus. Now let us take e power x common factor, rest of the term a into cos bx plus c minus sin of bx plus c into b. Take the substitution, a is equal to r cos theta and b is equal to r sin theta, where r is equal to square root of a square plus b square and theta is equal to tan inverse of b by a. If you substitute r, a and b value in the above equation, then y1 is equal to e power x into a value r cos theta to cos of bx plus c minus sin of bx plus c, b value r sin theta. Let us take r common factor and rest of the term cos theta into cos bx plus c minus sin bx plus c into sin theta. See, this term looks like a cos a into cos b minus sin a into sin b is equal to cos of a plus b. Here a value is bx plus c, b value theta. That is y1 is equal to r into e power x into cos of bx plus theta, a plus b. Similarly, y2 is equal to r square into e power x into cos of bx plus c plus 2 theta. And y3 is equal to r power 3 into e power x into cos of bx plus c plus 3 theta. And so on to differentiate n times, and yn is equal to r power n into e power x into cos of bx plus c plus n theta. So now let us substitute r and theta value here. Then yn is equal to nth derivative of e power x into cos of bx plus c is equal to r value if you substitute r square plus a square plus b square power n by 2 into e power x into cos of bx plus c plus theta value tan inverse of b by a. Note, if a is equal to 1, b is equal to 1 and c is equal to 0, then nth derivative of e power x into cos x is equal to, if we substitute a is equal to 1, b is equal to 1 in the above formula, then a square plus b square is 1 square plus 1, 2 power n by 2 into e power x, 1x to cos 1x plus c value 0 n into tan inverse of 1 by 1, tan inverse of 1, pi by 4, 45 degrees. If c is equal to 0, then nth derivative of e power x into cos bx reduces to a square plus b square whole to the power of n by 2 into e power x into cos of bx plus n tan inverse of b by a. The third condition, if a is equal to 0 and c is equal to 0, then nth derivative of above function reduces to cos bx is equal to, here a is 0, then b square whole to the power of n by 2, to cancel, b power n into e power x e power 0 1 into cos of bx plus c0 plus n tan inverse of b by a, b value b divided by a value 0, anything by 0 infinity, tan inverse of infinity pi by 2. Let us take related examples. Find the nth derivative of e power 3x into cos 4x. Let y is equal to e power 3x into cos 4x. Take nth derivative on both the sides. Then yn is equal to d power n of e power 3x into cos 4x. So this it is in the form of e power ax into cos bx. Here a value 3, b value 4. So the formula here a square plus b square. 3 square plus 4 square is 9 plus 16, 25 over n by 2 into e power 3x into cos of 4x plus n into tan inverse of b by a, 4 by 3. So let us take one more example. Find the nth derivative of e power minus 3x into sin 2x. Let y is equal to e power minus 3x into sin 2x. Take nth derivative on both the sides. Yn is equal to d power n of e power minus 3x into sin 2x. Here a value minus 3, b value 2. So my a square plus b square. 9 plus 4, 13 power n by 2 into e power minus 3x to cos of bx, 2x plus n into tan inverse of 2ab by a, that is 2 by 3. So negative sign, since angle is always a positive, here we are writing the amplitude. So for that we will take considering only positive value. Find the nth derivative of e power 4x into cos square 2x. See, we have standard formula only e power x into cos bx, e power x into sin bx. We don't have e power x into cos square or sin square. If the cos square or sin square comes, that has to reduce to power 1 by applying the appropriate formula here. Now see, look at here. Let y is equal to e power 4x into cos square 2x. E power 4x into cos square 2x can be written as 1 plus cos 4x by 2 is equal to 1 by 2 into e power x into 1 e power x plus e power 4x into cos 4x. Now both the terms is in standard form to apply nth derivative. Then y is equal to nth derivative of 1 by 2 into e power 4x plus e power 4x into cos 4x. The first term nth derivative a power e power x nth derivative a power n, a value 4 power n into e power 4x plus a value 4, b value 4. That is 4 square plus 4 square, 16 plus 16, 32 power n by 2 into e power 4x to cos of 4x plus tan inverse of b by a, 4 by 4 1, tan inverse of 1 by 5. One more example. Find the nth derivative of e power minus 2x into cos h of 3x into sin 4x into sin x. Let y is equal to e power minus 2x into cos h 3x into sin 4x into sin x. Now here cos h 3x can write it as in the form of exponential e power 3x plus e power minus 3x divided by 2. Hyperbolic function converted into exponential form into sin 4x into sin x. E power minus 2x into e power 3x plus e power minus 3x divided by 2 into sin 4x into sin x. Now 1 by 2 into e power minus 2x should multiply both the terms. E power minus 2x into e power 3x is minus 2 plus 3 plus x into sin 4x into sin x plus e power minus 2x into e power minus 3x is e power minus 5x into sin e power minus 5x into sin 4x into sin x. Now again this sin 4x into sin x it is in the form of sin a into sin b. Again we have to apply the formula sin a into sin b is minus 1 by 2 into cos of a plus b minus cos of a minus b. Here minus 1 by 2 into cos of a plus b 4x plus x 5x minus cos of a minus b 4x minus x 3x plus e power minus 5x into minus 1 by 2 into cos of a plus b 4x plus 1x is cos 5x minus cos of 4x minus x is cos 3x. So we can take minus 1 by 2 common factor and then you apply nth derivative on both the sides. 1 by 2 to minus 1 by 2 minus 1 by 4. Then nth derivative of e power x into cos 5x e power x into cos 3x plus e power minus 5x into cos 5x minus e power minus 5x into cos 3x. Now, so the first term nth derivative a value 1 minus 1 by 4 into a value 1 b value 5 1 square plus 5 square 1 plus 25 26 power n by 2 into e power x into cos of 5x plus n into tan inverse of 5 by 1 minus the second term nth derivative a value 1 b value 1 1 square plus 1 square 1 plus 1 2 power n by 2 into e power x into cos of x plus n into tan inverse of b by a 1 by 1 tan inverse 1 5 by 4 plus third term nth derivative a value minus 5 b value 5 25 plus 25 50 power n by 2 into e power minus 5x into cos of 5x plus n into tan inverse of b by a minus 5 divided by 5 by minus 5 tan inverse of 1 tan inverse of 1 here 5 by 4 minus the fourth term nth derivative here a value minus 5 b value 1 25 plus 1 26 power n by 2 into e power minus 5x into cos of x plus n into tan inverse of b by a 1 by 5. One more example here. Find the nth derivative of e power x into sin x into cos x. Let y is equal to e power x into sin x into cos 2x. So we can't apply nth derivative directly. So sin x and cos x should make it separate term by applying the sin a into cos b formula. See 1 by 2 into sin of a plus b x plus 2x is 3x plus sin of a minus b x minus 2x is sin of minus a sin of minus theta minus sin theta. So for that here we written e power x into 1 by 2 into sin 3x minus sin x. So now you can multiply e power x with both the term and then you take nth derivative on both the sides. Yn is equal to nth derivative of 1 by 2 into e power x into sin 3x minus e power x into sin x. The first term nth derivative 1 by 2 into a value 1 b value 9 1 plus 9 10 10 power n by 2 into e power x into sin of 3x plus n into tan inverse of b by a b by 1 minus second term nth derivative a value 1 b value 1 so 1 square plus 1 square 1 plus 1 2 power n by 2 into e power x into tan into sin of x plus n into tan inverse of b by a 1 by 1 tan inverse 1 5 by 4 and these are the references which we use to prepare this video. Thank you very much.